Hi 171, I wanted to make this quick video to review what we talked about in section 1.10 about regression lines and how to do that inside of Desmos. So I'm going to hide my face and get the Desmos screen and your WebAssign assignment up to kind of walk you through how to input that data into Desmos. Alright, so here we have the screen. We've got your WebAssign on the left and we've got Desmos on the right. So we're going to go through doing this first problem. Right? And so over here in Desmos, I want to create a table so that I can put this data into it. So to create a table, we go to Add Item and Table, and notice we've got the variables x1 and y1. Now for this particular problem, it says using a graphing utility to create a scatter plot of the data and t equals 7 representing 1997. So we're going to start at 7 and go all the way up to what would be 2014. So we'll go there for now. I may need to add more in a minute. And now we're going to type in the y values. Alright, so I've got my data entered. I'm going to change it back to what you will default see. Alright, so this is what you should default see whenever you open Desmos and start graphing. Notice in the default view you're not going to see these data points because the minimum starts at 558. So if I come up here to the settings, I can change my x value start. Well, we can keep that at 7 because over here the graphs and WebAssign start at 0. So change that to 0 and they go up to, it looks like 25, and they step by 5 each. And we're going to just label that T because that's what it is in WebAssign. And then the Y values in WebAssign also start at 0. Now here's where they're different. So the choices, some go up to 1400, some go to 2000. So let's do 2000 since that's the highest, and they step up by different. So let's do 500 just to get a glimpse. Alright, so I have the graph that kind of looks like this. So we can quickly eliminate the bottom two options because they are going down as where our data seems to be going up. But if I notice this dot right here, its maximum value is 1365, which is less than 1500. As we're in this one top right one, like it's at 2000, it's got dots above 2000, so that is clearly eliminated. So our answer choice we're going to go with is answer choice A in this case, or the first answer choice. Alright. So now the second question says use the regression feature of a graphing utility. Well, Desmos is our graphing utility, so we need to figure out how to do regression inside of Desmos. So to do that, we need to create a relationship between y1 and x1. So you would think y equals mx plus b. Well, we don't want to do that exactly. What we really want is to do this squiggly symbol. So how do I get that squiggly symbol? If I go to the keyboard and click ABC, then it is right down here, second over from the enter button. So there's the squiggly. Now again, it's telling me, well, y maybe not be used as a regression parameter. Well, that's because this is y1. So I can change that to do y1 and make this x1. And we see there it creates this regression line. So let's make it black and dotted. Okay. So this is the line that is approximating the points that we have. So we see here, this would be our data. The question is, what is this equation? So notice we've got our M value to be 44.9783. So our question says round everything to one decimal place. So if I round 94.9783 to one decimal place, that's actually going to get rounded to 45x plus, and then we've got that B value, which is 192.5. And so here we see that this blue line is approximately the same as that black line. So this is our regression. Now if I take this and enter it into WebAssign, I'm going to get counted wrong. Let me show you that. So notice, even though we did all the math correctly, this is incorrect. Because notice here, it's asking for S of t, which means the variable that I should use is a t. So now let me check my answer again and show you that if I do not use the correct variable, WebAssign is going to count it wrong. Alright, so we're good. And we got this one right too. Alright, so how closely does this model represent the data? Well, it is a good fit of the actual data. Notice how close the line approximates these points. Quantitatively, we can look at this R value right here. Let me zoom in. We can look at this R value right here, and since it is really close to 1, that is a good fit for our data. And then now it says use the model to predict the gross ticket sales during the season in 2021. Okay, well, if we go back to our table, remember it started at t equals 7, and t equals 7 was 1997, which means that 0 would be 1990. So the question is, how many years is 2021 from 1990? And that's 31 years. So if I put 31 into this function, that's going to give me my approximate ticket sales. And that gives me a grand total of 1,587.5. Now, I want to stop there and talk about this number. So if you notice, these ticket sales are in millions of dollars, and this is Broadway season ticket sales. And then our T is in time since 1990. So what this is really saying is that is $1,587.5 million, and 1,000 million is a trillion. So a better way to say this number is actually this is $587,500,000 in ticket sales to Broadway shows, and that would be the slope. Or sorry, that would be the predicted value in 2021. My apologies. The next says interpret the meaning of the slope of the linear function. Well, the slope was 45. So here we have that the gross ticket sales for Broadway shows in New York City increased by about $45 million each year. And so now I'm going to submit all these just to show you that this is how you would enter your answers completely into Blackboard. And so we got everything 100% correct. Alright, so that's how you can complete number 1. The same thing is going to happen here, except in this problem they already give you the regression line, starting with t equals 6, so our start date is actually, in our formula, is going to be 2000, so forth and so on. So I hope that's a helpful little view on how you can use Desmos to look at the points and analyze this. Remember, our R value, which is called the correlation coefficient, is the value that we're looking for in order to determine whether it is a really good fit for the actual data.